Hello, I'm Stephen Brown. I'm a professor of physics at the University of Warwick. So it was 1993 in my final year of my degree course at Oxford in chemistry, and I had to choose the final year project, and I chose one in solid state NMR with my future PhD supervisor, Steve Wimperis. And when I started that, I wasn't thinking I was going to stay in research, but the part that fascinated me, the project that sort of Steve set me on to start with, was they'd done an experiment where they were seeing an extra feature they didn't understand, and also so Steve had written a simulation program for implementing some of the quantum mechanics of the density matrix for a different case, but it needed expanding for this particular application. So I enjoyed the programming in Fortran. This was before, nowadays there's this software like Simpson where it's all done for you. In those days that software didn't exist. And so I remember being able to do a simulation that matched the experiment. I thought, this is cool. And I think that's one of the things I like most about NMR. And when I teach it, it's actually saying it's you can explain many experiments by the simple matrix maths of one or two spins. And so you can have an idea, you can write the analytical equations out, you can do the simulations, you can do the experiment, and they all tie up together. So that was really what brought me into it as a subject, and thinking, yeah, I could actually enjoy doing a PhD. Yeah, so it's a question of sort of how does NMR relate to, or how does solid state NMR relate to other analytical science techniques? And yeah, so from that one I can say, because one of my roles at Warwick is I'm director of the Warwick Analytical Science Centre. So as that I get to see the other analytical science methods, and particularly my own research, obviously for solid state characterization, the gold standard would be single crystal X-ray diffraction, but there are many cases where you cannot actually get a crystal structure. So in those cases, you're relying on complementary techniques, so power diffraction, and also calculation. So a lot of our work in the field of NMR crystallography brings together experimental characterization via the solid state NMR and also the complementary diffraction with calculations where you have a structural model, a solid state, be it from a simulation or a crystal structure prediction approach. So yeah, I always see that solid state NMR is complementary, and it's interesting to observe. I've worked closely with industry for many years, and there you see that the industry will have experts in all of the relevant analytical science methods, and they'll work together. And also, so for this analytical science centre I'm involved in, there's an MSc course at Warwick in analytical science where the students are then exposed to all the methods. And we're saying that you hear about the strengths and weaknesses of a technique, so you can see where you apply one and where you apply another.